Good morning, everyone. Welcome to ProMat 2023. Welcome to, sponsored by MHI. Welcome to the Robotics and Automation Theater, sponsored by DC Velocity Magazine. So excited to have you on the first opening day of ProMat, so welcome. We're going to start with Innovations in Item and Parcel Sortation, presented by Tompkins Robotics. Sean O'Farrell, Vice President of Operations for Tompkins Robotics. Let's give him a warm welcome.
Thank you, Hallie. Can you guys hear me okay? Good morning. And let me say a happy first day of spring to you and welcome to Chicago. I know it's kind of cold here. I live in Florida. My name is Sean O'Farrell. I'm Vice President of Operations with Tompkins Robotics. I joined the company about 15 months ago, but I've been in the industry for quite some time, and I was just figuring out that my very first ProMat was back in 1987. So that kind of makes me old. And some of the stories of how cold it gets here in Chicago is kind of interesting. So that makes, I think I was saying I was doing about 18, this is my 18th one, but I didn't come during COVID, so this is my 17th ProMat show. So I've seen a lot of changes and innovations over the years, and I'm really excited to be here. It never gets old. I love the fact that there's a robotics hall now, and I'm going to speak to some of that today. We're going to have a Q&A session at the end, so either hold your questions till then or you might be able to ask them if you want, but we'll have a microphone, if necessary, to pass around for the Q&A. Well, let me just start by saying, what are some of the key takeaways that you should experience today? So, first of all, you should have gained an understanding of what types of technologies are out there for the item and parcel sortation. We're going to talk a little bit about the past and what has been used in the past and what the costs are for some of those solution sets. But we're going to talk also about the future and a lot of the technologies that you'll see here at ProMat while you're visiting. We'll talk about how you can combine technologies to be able to integrate a total solution that will help your operation have a great return on investment, also have great efficiencies based on labor savings, space savings, flexibility, and also having a path forward on how you can expand and grow the facility. So, as most of you know that are here, maybe on behalf of your company, and they're looking for ways to save money and get into the automation game, it's all about low risk, right? And what if the industry changes on us or our business changes in the next couple of years? What if there's another pandemic or anything else that happens, mergers, acquisitions, competition, all of those things? You want to make sure that you have the most flexible system available to you. So we'll talk about that and a little bit about the ROI benefits of using the different types of automation. So traditional distribution and fulfillment operations have used manual labor in the past. As you know, with 3% unemployment and those who don't want to work in tough or difficult environments, it's become more challenging to be able to do what you want to do within your facility by lowering cycle times, lowering touches, increasing the quality of the product, and things like that. So what we're going to talk about is how it's an expensive capital outlay for the older type systems. When you talk about the Bombay sorters, tilt trays, cross belt sorters, some of those that you might have that in your operation right now, you know it was a big capital outlay, and as a result of that, it took up a lot of floor space, and usually a building was built around that. But as you grow, how do you leverage that technology if it might be 10 years old, 5 years old, 20 years old? What can you do to get more out of what you currently have? Or if you're looking at going towards a new solution or even a new building or a building expansion, what kind of technologies are out there for you? So, as I said, they require a large space. When you think about the Bombay sorter, the technologies that compete against that today, talking about the AMRs, the autonomous mobile robots, those things take about half the floor space of what a Bombay sorter would take. If you look at the tilt tray, it takes about a third of the floor space, and the same with the cross belt. So when you talk about new building construction for a warehouse that might be shaped like this with a 40-foot clear ceiling, you might be talking upwards to $150 to $200 a square foot. So it's important that when you're designing the system that you use the right technology and you don't build for 10 years out, you can do a scalable approach, a crawl, walk, run. So one of the favorite things I like to talk about is the companies that do not have any automation right now. So I've been with Tompkins Robotics for the last 15 months, and I was with Dematic for 10 and a half years before that, and before that I was with Witron, and before that I was with Daifuku. And you might think to yourself, well, that's a lot of different companies, but I had a lot of great different experiences, but the key thing was helping customers. So the reason I joined Tompkins was the technology, and this is not supposed to be an advertisement, but we have a booth here on the floor, it's just a couple aisles away, and our technology is such that those companies that want to get into automation and need to get into the game because of competition, unemployment, capital, leveraging your existing operation, is such a low-risk approach for doing automation. And I'll touch upon that a little bit later not speaking specifically to Tompkins, but to other companies, some of our peers in the industry. A little bit on the long delivery installation time. As you know, with the supply chain issues, that impacted a lot of things, but the steel has gone up quite a bit in pricing, and so that becomes an important component when trying to justify a project. You know, a lot of the U.S. companies still have that, you know, can it pay for itself in 2 years' time, 3 years' time? When you're talking about a large bomb-based system or a tilt tray, things like that, that can be anywhere from 9, 18 to 24 months in length of time to do the project, be fully operational, and have your workers trained on using that. The AMR aspect of it is about 3 to 6 months, and you can start small, and if you want to add more vehicles or robots when the peak season comes, you can do that, because a lot of these companies are offering not only just capital outlay, they're doing leasing, but also robots as a service, which has really come on strong, especially for the 3PL companies out there. So you'll hear a lot about that today, especially when you're walking the floor, about some of the 3PL companies that are partnered with some of the AMR companies to get in the game. They can't find the labor, they need to do things differently. So that's an exciting thing, and again, when you're only talking about 3 to 6 months, we have a lot of companies that we're dealing with right now that are embracing that. So it's, you know, what we're talking about is the simplicity of the technology. So when you look at doing a highly automated system, you're talking about having to have a maintenance department, and a lot of companies will have engineering departments as well in order to handle the highly integrated technologies and automated systems. With the AMR side of the business, we're talking about people that could have an 8th grade education that can manage the AMRs. If an AMR goes down, you can pull that vehicle off and put another vehicle on. Very simplistic to do. You don't have to have an engineering department, and again, a low-risk way of getting into the automated game. We also have issues with lack of redundancy and single points of failure. I just hate it when when companies have issues. I remember working with a company one time that had a tilt tray sorter system. They did a lot of retail goods to the retail stores. They had like 1,000 stores in the U.S. And one time a boom truck was doing some electrical repairs. They had a contract employee that was driving the truck. And between the two buildings was a Skyway conveyor system that linked the picking and tilt tray sorting aspect to the shipping sorter for the parcels. And the boom was left up, and they hit the overhead passway or the bridge, pulled a couple sections of conveyor down, so all hands on deck had to go up there. Mostly a lot of the executive team that was based in this, on this campus had to do basically the bucket brigade of handling product hand to hand or putting it on carts to get product out the door. So that's what happens when you have some initial problems like that. So with the AMRs, autonomous mobile robots, you don't have to have that single point. So very important to have. And then, of course, the fixed mechanical structure. A lot of technologies, when you see some of the AMRs out on the floor, it's not fastened to the floor. They can operate anywhere. Some operate with QR codes, some operate with RFID chips, but it's very important that you keep some of those technologies clean for the operation. But with the autonomous mobile robots, they can go around product that might be dropped on the floor. their navigation systems are reliable and very safe to use. High energy consumption, when you're talking about an AMR with a battery or standard 110 operation versus something much larger, that can be very expensive for customers. We like to say our technology consumes about as much electricity as your dryer in your house or your apartment that you use in a day's time. And also, the AMRs can operate anywhere from 4 to 12 hours on one charge. So that's pretty important for a lot of companies out there. A lot of them most of them are opportunity charging. So when they know they're getting low on charge time, they'll go plug itself in, and the companies will allow for that. So a lot of them will simulate the solution to make sure that they have enough capacity for that operation. So if they're doing 10,000 moves per hour, they make sure they have about 12,000 moves per hour within the AMR system, make sure they account for the charging time, any unforeseen circumstances, if there happens to be a filled location or something like that. So some pretty good technologies out there as well. And of course, when you have items that are fastened to the floor, it's not easily scalable or things like that. So we're working with one customer who has a sorting system already, but their retail store growth has grown such that they need more locations, sort destinations to refill a retail store because they've added more stores, another like 200 stores. So they have a footprint about this big in which we're expanding into the system to be able to do an additional 150 sorts for that customer using AMR technology. So we'll talk a little bit about that using a multi-level type table system that can operate in small footprints, 6 months project receipt of order to being operational and tested and training on it in a very clean environment. So we're going to reference our favorite group, the MHI group, which is hosting the ProMat show today. But they did a report. They do one annually every year. Their 2022 report came out where they've interviewed 1,000 supply chain professionals. And only 28% of the companies out there are using some form of automation or robotics in their operation. And they see an increase of 51% using automation over the next 5 years. Well, what does that mean? Well, there are a lot of companies that are starting to look at doing $1 million type systems, and that's about 66% of the companies out there. And then the middle portions, 5 million to 100 million, that's about 41% say they're going to spend more than 5 million, and 18% say they will spend more than 10 million. So I'm sorry, that's a typo. So it should be 5 million up to 10 million and then beyond that. So we're seeing a lot of high levels of automation with a lot of companies, but we also see those companies that need to get in the automation game, and the AMRs are proving to be quite beneficial for those customers so they can compete against the market leaders like Amazon or Walmart or UPS or FedEx and things like that. So some of the technologies we want to talk about from an AMR perspective, we've got pick-and-place robotic arms that you may see in the marketplace. You also, actually here at ProMat, pick assist, AMRs, autonomous mobile robots. You have goods-to-person AMRs. We also have automated storage and retrieval systems, which I'll cover in just a moment. And then sortation AMRs, or some of them are like pedestal robots that can do parcel sortation or even tote sortation, case sortation. So here's a couple examples of some of those technologies I just covered on the previous slide. And if we look at the first one from the left, the pick-and-place robots with sortation AMRs, this is a great technology. We partnered with a number of robotic arm type companies like Covariant, Plus One Robotics, Mujin, and others, Right Hand Robotics. And the technology I like for this, and a lot of our customers like, is that the robot does not care if it has a barcode facing up where it can read it or not. So if that parcel comes down and has the barcode on top, they suck that parcel, that envelope where that package might be, place it onto the yellow robot, and then the camera above will scan that, and then the robot will go to its sort destination. If the barcode happens to be on the bottom, the vehicle will, the robotic arm will handle that package, and it'll pass by a scanner so it can scan underneath, so you can get high throughput, anywhere from 6, 7, up to 1,000 inducts per hour with a robotic arm. So customers are looking at that type of technology, which is quite exciting. The one in the middle, we complete with a partner in which they provided the ASR system, the robotic arm. They're picking from a tote to a tote, but they could also put onto an AMR robot if necessary. And then the last technology is showing a goods-to-person, a robot picking up a shelf, bringing it over to an induct operator. The induct operator takes that item off the shelf, and there's usually a laser scanner that'll point the operator where to go and what to pick and how many to pick, and they'll place it onto that goods-to-person, or excuse me, the AMR robot, the yellow one, and they'll take that away to a sort destination. So it's pretty powerful what these technologies can do once you integrate them all together. This is a slide that is starting to make a lot of sense for companies. So when we talk about ASRS companies like AutoStore, Exotech, Multi-Shuttle, other types of automated storage retrieval systems out there, when you couple that with an AMR system, you've got a very powerful operation. So we're talking about the robotic arm picking from a tote and putting into a tote. We did a system with a customer last year that has an AutoStore system, so that operator at the port can actually pick items from the side and then induct it onto one of 4 spots, on 2 on the upper level and 2 on the lower level. And the throughput that operator is getting out of an AutoStore port now, based on being able to batch pick and then sort to different robot locations, is about 1,000 items per person per hour. So they're able to leverage the throughput of the AutoStore quite a bit. And we're seeing it with other ASRS technologies. And now you talk about the sort destinations on something like that. You could have as few as 10 sort destinations, or you can have thousands of sort destinations. This example here would probably be a retail store replenishment because they're using a tote to sort into, and that happens to be a 2-level system. So that customer that has well over 16 ports in their AutoStore system, 2 of the ports have a robotic arm that's picking and placing it onto the robot. So they see migrating to more automation in the future. So they're starting small. 14 of the stations have manual picking and placement, and then 2 stations have full automation. And just to give you a little idea of what's being transpiring up here, this is a tSort system, and it has a highway that's running parallel with the AutoStore system, and then the 3 fingers is what it's called, that the vehicle will run down and sort to that particular destination. It happens to be a 2-level system, so you can have more sort destinations, and now there's technologies where you could have it up to 5 levels high, depending on what the requirements are for your operation. So another case study is a customer handling medical products, and they're using a GTP AMR, a goods-to-person robot that picks up products from a staging or storage area, bringing it over to one of multiple induct points. I think it's about 15 or 14 induct points. And they're able to get an increase in throughput out of their operators. So they're increased by from 225 lines per hour up to 360 lines per hour, which is an increase of well over 60%. So simple little technologies and solution sets will help increase the productivity as a result of that. They're doing batch picking. That person that, I don't have a pointer, but where the operator is, there's 2 robots staged on the upper level. And that person can induct upwards to 1,500 per person per hour. The order presentation gives them 8 induct points on the system itself, and up to 400 sort positions for that order for that person. Another set of innovations on the left here. This is a lift operation. They're using simple elevator technology where a person will induct whatever that height is for that operator. It can adjustable type station for ergonomics, and they have 2 lifts or 2 elevators side by side. So that person, once there's batch picked items or maybe items that are conveyed over to them, They place it on each elevator, and it goes up to 5 different levels on the sortation system. The throughput of some technology like that is 600 per lift per hour. So one person could conceivably do 1,200 inducts per person per hour, then sorting to a destination, whether it's an e-commerce order, a parcel item in which you might be filling a gaylord and doing some zone skipping or routing, or into what is called a 3D sort module. And then now with additional technologies to try to get as automated as possible, once that tote position or even that gaylord or postal bag fills up, you can have a robot that will come over and pick up that item. So the second image depicts an AMR, autonomous mobile robot, that will actually, in some examples, there are 5 or 6 positions on the robot mast itself. So 5 of those positions would have an empty tote in it. It would come over to a full tote position, pick up that full tote, bring it in, place it on the empty spot on the mast of that AMR, and then the mast will go, or the crane load handling device will pick up the next empty tote, bring it out, and put it into that vacated spot, and the system continues operating while that's all being done. And once that mast on the exchange robot is full, then it'll take it over to a pack station, or potentially to a shipping operation or whatever it might be. And it can do pretty high throughput with today's technology that will help customers become to an automated state, a fully automated state if possible. So I'm wrapping up early because I was so excitable with being the first presentation of the conference. But in summary, we have robotic automation that can really help in your operations. I can't express enough how easy it is for companies that have not done automation can look at a lot of solutions on the floor here that will let you get into the game at a very cost-effective way. And I'm happy to field any questions you might have. Happy to entertain you in our booth, or if you want a business card, you want to reach out later on, I can do that as well. So very low risk, and that's all I have. So may I field any questions in the audience? Yes, sir. Oh, hold on a second. I got my favorite Hallie coming over.
You were talking about charging the robots. Can you get it to charge at like peak times? You know, when electricity is cheaper, we can get it to...
Yeah. I'm speaking specifically to the technology I know. So when our robots get low on energy, we set it at 80%. So if the battery gets below 80%, it'll go over and get a drink. Every 5 to 8 minutes of charge time yields about 4 hours of operational time. So, and again, we plan that in because we simulate all of our concepts and our projects to make sure we have the right number of robots available for that customer. And more importantly, the customers are saying, okay, it's great that I don't have to look at a 7-year planning horizon, which is always challenging. If I can just do the 2-year planning horizon, why don't we just put automation in there? But can you simulate just in case at the 5-year mark we're going to be 50% larger than we are right now? So we do that on behalf of our customers, and they come to embrace that because, again, it's the low risk, non-threatening, and then we're talking about adding robots on. Thank you for that question. I want to thank you all. I'm sorry I finished up early, but again, happy to come to your operation and give the presentation. Unless you're my competition out there, I won't do that. Unless you want to feed me lunch, and then I'll do that. But I just wanted to point out our booth is booth 7140. If anybody would like to learn some more, I've got a lot of people over there that are much smarter than I am. And I think you'd like the technology. We can show you how it works in your facility. Thank you all.